A steel plate of constant thickness 14 mm is having a breadth of 120 mm at one end and uniformly varies to a breadth of 80 mm at the other end. Find the total extension due to an axial pull of 100 kN at the ends. Take E is equal to 206 kN per mm square and the length of the plate as 900 mm. Here is given a steel plate. So we can say it's a rectangular plate because here thickness is given. Okay, na? Thickness and breadths are given. Here breadth of 120 mm at one end and breadth of 80 mm at the other end. So it's a rectangular plate. Okay, so this rectangular plate is having a thickness of 14 mm. So here, first of all, let us write given data. Later we will see what we need to find and all. Given data. First, thickness of the plate. First of all, given thickness. T is equal to small t is equal to 14 mm. Next, given at one and breadth of 120 mm at one end and uniformly varies to breadth of 80 mm at other end. So initial breadth. Okay, now initial breadth or breadth at one end. B1 is equal to 120 mm. Now final breadth, minimum breadth. So maximum breadth 120 mm, minimum breadth enta B2 80 mm. Okay, next find the total extension due to an axial pull of 100 kN. So here axial load or axial pull P is equal to capital P is equal to 100 kN. So let us convert it into newtons. 100 into kilo means 10 cube. Okay, no? Into 10 cube Newton. And also given Young's modulus. Young's modulus is equals to 206 kilonewton per mm square. Kilonewton per mm square. Young's modulus kilonewton per mm square. So E is equal to 206 kilo means 10 cube Newton per mm square. So we also given length of the plate. L is equal to 900 mm. Okay, this is all about given data. And at final we need to find total extension due to an axial load. Total extension or change in length of the rectangular plate. So anyhow, here there is a steel plate of constant thickness 14 mm or rectangular plate of thickness 14 mm is having a breadth of 120 mm at one end and uniformly varies to a breadth of 80 mm at other end. Okay, na? Let's try to draw the diagram. So there is a steel plate. Okay, na? There is a steel plate having initial breadth 120 mm, nothing but B1, and breadth reduced uniformly. Okay, na? So what is the final breadth? Final breadth is 80 mm given. 80 mm. Okay, and this rectangular plate. Okay, na? This rectangular plate is having thickness. Given thickness T is equal to 14 mm and the length of this rectangular plate is 900 mm denoted by L. So this rectangular plate is subjected to an axial pull at both the ends. So an axial pull of P is equal to 100 kN. Okay, due to axial pull this rectangular plate elongates in the direction of loading. Okay, so we need to find change in length or extension of this rectangular plate due to an axial pull of 100 kilonewtons. సో ఎప్పుడైతే మనం యాక్సియల్ లోడ్ అప్లై చేస్తామో ఈ రెక్టాంగిల్ ప్లేట్ ఏమవుతుంది, ఎలాంగేట్ అవుతుంది. ఓకేనా, చేంజ్ అవుతుంది కదా, చిన్నదైనా మైన్యూట్గానే చేంజ్ అవుతుంది కదా. సో ఆ చేంజ్ ఇన్ లెంత్ ఫైండ్ అవుట్ చేయాలి. Okay. Anyhow, in case of rectangular plate, change in length formula. Change in length is equal to, whenever a rectangular plate is subjected to axial pull, change in length is equal to, there is a formula PL by TE into B1 minus B2 into log B1 by B2 to the base E. So this is the formula for extension of rectangular plate or change in length of the rectangular plate. Okay, using this formula we can find the value of change in length of rectangular plate. Now delta L is equal to change in length or extension of the rectangular bar or plate. Okay, in mm. So delta L is equal to, what is the formula? Delta L is equal to PL by TE into B1 minus B2 into log B1 by B2 to the base E. So logarithms which are calculated to the base E are called natural logarithms. This type of logarithms are called natural logarithms or Neperian logarithms. Okay, so this logarithm name is natural logarithm or Neperian logarithms. Okay, delta L is equal to, let us replace all the values. Here P is equal to, what is load? P means load, axial pull. How much? 100 into 10 cube into length 900 mm by thickness 40 and Young's modulus given, I think 206 into 10 cube into B1 minus B2. B1 maximum thickness, maximum breadth, initial breadth 120, final breadth 80 into log B1 by B2 120 by 80 to the base. 0 get cancelled, 4 2s 4 3s, 10 cube get cancelled. Okay, now delta L is equal to 100 into 900 by 14 into 206 into 120 minus 80 40 into log 3 by 2 to the base. Delta L is equal to 0 get cancelled, 4 1s 4 25s 100, 25 into 90 by 14 into 206 log 1.5, 3 by 2 means 1.5 to the base. 2 7s 2 45s, 25 into 45 by 7 into 206 log 1.5 to the base, delta L. Now delta L is equal to 25 into 45, calculate 25 into 45, you will get 1125 and 7 into 206, so 7 into 206 value around 1142 log e to the log 1.5 to the base e, so this value will be 0.1761. Okay, remember log e means which logarithm? Natural logarithm. Okay na, do not use ln. Okay na, log e. Okay, so ln means common logarithm. That okay na, so common logarithms are calculated to the base 10. ఇక్కడ e ఉంది కాబట్టి మనం షూర్ గా క్యాలిక్యులేటర్ యూజ్ చేసినప్పుడు షూర్ గా మనం ఏమి ఇచ్చేయాలి, log e ఇచ్చేయాలి, LOGA ఇచ్చేయాలి, delta L. So if you calculate this, you will get final answer 0.1374, approximately 1374 mm. Therefore extension of the rectangular plate is 0.1374 mm. Okay na, just remember this formula. So this formula use it for to find extension of the rectangular bar or rectangular plate when subjected to axial pull of some P kilonewtons, some P newtons.